Hello everyone, I am Ümit Alkuş. In this video, we will solve one problem in chapter 29. A. Using the Biot-Savart law, find the magnitude and direction of the magnetic field at point P, which is a distance r from a current-carrying wire of infinite length. The Biot-Savart law is the following. Assume there is a current-carrying wire. If we take an infinitesimal length vector ds, I times ds is called the current length element. At any point P, which is a distance r from this segment, the magnetic field is calculated as mu0 over 4 pi times I times ds cross r over r cubed, where mu0 is magnetic permeability of free space, and it has the value 4 pi times 10 to negative 7 Tesla meters per ampere. The direction of the magnetic field is attained by the right-hand rule. In this figure, the magnetic field is into the screen. Anyway, let us turn to our problem. For our current-carrying wire of infinite length, let us choose the origin in the line of the distance r. Assume that the wire lies along the z-axis. Therefore, positive infinity goes here and negative infinity goes here. From the origin at a distance c, take an infinitesimal current length element I times ds. Because it is along the z-axis, we can write IDS equals IDZ k hat. Point P is at a distance r from the length element, where theta is the angle between the current element and the position vector r. In the figure, there is a right triangle, and r can be found by the Pythagorean theorem as square root of r squared plus z squared. The direction of the magnetic field at point P is found by the right-hand rule as into the page. The magnitude of the magnetic field is mu0 over 4 pi times I times ds times r times sine theta over r cubed. Because of the cross product ds cross r, 1 r's cancel each other. Therefore, we have mu0 over 4 pi times I times sine theta ds over r squared. We know that ds is dz. As a result, dv equals mu0 over 4 pi times I times sine theta times dz over r squared. If we draw a unit circle, we see that sine theta equals sine alpha. In the right triangle formed ZRN capital R, sine alpha is capital R over R. So, sine theta is capital R over R. Finally, dB is obtained as mu0 times I times capital R over 4 pi times dz over r cubed. Here, r is square root of capital R squared plus z squared. Thus, we write mu0 times I times r over 4 pi times dz over z squared plus r squared to the power 3 over 2. The right-hand side is over z. If we take the integral of both sides, the left-hand side is just b. The integral limits on the right-hand side are negative infinity and plus infinity. Or simply we can write 2 times integral from 0 to infinity mu0 times I times r over 4 pi times dz over z squared plus r squared to the power 3 over 2. 4 is simplified by 2. mu0, I, r and pi are constant, and they can be taken outside the integral sign. From the integral table, the integral is 1 over r squared times z over z squared plus r squared to the power 1 over 2 with the integral limits 0 and infinity. R squared is simplified by r to obtain mu 0 times I over 2 pi r times z over z squared plus r squared to the power 1 over 2, where z is infinity, minus 0. Because r is constant and small compared with the z, the first term becomes z over z, which is 1. Finally, magnetic field is found by the formula mu 0 times I over 2 pi r. B. Using the result you have found, express the magnitude of the magnetic field at a point which is a distance r from the beginning of a current carrying wire of semi-infinite length. The integral to find the magnetic field of the infinite length have the limits negative infinity and positive infinity. We know that it is twice the integral from 0 to infinity, where the integral is for the semi-infinite length. Hence, we can write the magnetic field of the semi-infinite length as 1 over 2 times mu 0 I over 2 pi r, where mu 0 I over 2 pi r is the magnetic field of the infinite length. So, we write mu 0 I over 4 pi r. C. Using the Biot-Savart law, find the magnitude and direction of the magnetic field at point P, which is the center of a 5 radian current-carrying circular arc of wire of radius r. The Biot-Savart law for the magnetic field states that mu 0 over 4 pi times I times the s cross r over r cubed. In the figure, on the wire, let us take the current length vector I times ds as the following. Point P is at a distance r from this length. By the right-hand rule, the direction of the magnetic field at point P is out of the screen. The cross product ds cross r is ds times r times sine theta. So, the magnitude of the magnetic field is mu 0 times I over 4 pi times ds times r times sine theta over r cubed, where theta is the angle between vectors ds and r, which is 90 degrees, which leads to sine 90 degrees as 1. After that, we have mu 0 times I over 4 pi times ds over r squared. R is the radius capital R of the circular arc. Now, we can take the integral of both sides. The integral of dB is the total magnetic field B. On the right hand side, mu 0 I 4 pi r squared are constant, and they can be taken outside the integral sign. Then we are left with the integral of ds. The integral of ds is the total length, which is r times phi. R squared is simplified by r. Therefore, the magnetic field is obtained as mu 0 times I over 4 pi r phi. Remember that the angle must be in radians, not in degrees. Finally, we can write the magnetic field at point P as mu 0 times I over 4 pi r phi, which is out of the screen. Alright, we are done. Thank you for your attention. See you in the next video.